So let's start with the properties of numbers. So of numbers that we know are which type of numbers? Can you tell me? Whenever I speak of numbers, which is the first number that you think of usually? First number, let's say first number. 1 is the first number that usually we think of, because we don't want to start on a negative note usually. So 0 is not the first number that we think of. We start from 1, right? So 1, 2, 3, 4, 5, all these kind of numbers I can think. So tell me a number. So let's say 8, 23 or 122. So what are these numbers called as? These numbers are called as natural numbers. Natural numbers. That's my basic or starting natural numbers. Okay. Then let me include a 0 in my counting, because 0 was not included so far. So including a 0, now the numbers will be called as whole numbers. Correct? Now the numbers will be called as whole numbers. Then if I include negative numbers in my counting, then what will be the numbers called as? See, so far I had a 0 and 1, 2, 3, 4, 5 up to infinity. Now I'm expanding my counting on the negative side as well. So now the numbers are called as integers. Very good. So whole number plus integers, sorry, whole number plus negatives will give me integers. Can you tell me what would come after integers? Now, what is something that I have not included so far, but now I can start including? Decimals. Very good. So decimal points I have not included so far, which I should start including. Prime numbers are already considered, Surya. Fractions. Yes, absolutely right. So far I was not using any fractions. So now I should start using fractions. So fractions are like this, or decimals like this. So including them in my counting, what will be the numbers now called as? So if I include fractions into my integers, then they will be called as rationals. Very good. They will be called as rationals. Okay. Then in the rationals के बाद में there are certain things that I can add. If there is something rational, then there must be something irrational as well. So if you add irrational into rational, then what do you get? Irrational and rational put together, what do you get? Real numbers. Yes, that is correct. We get real numbers. And what are irrationals, by the way? Something like this: pi, root 2, cube root of 4, and things like that are irrational numbers. Correct? Surya, just wait for some time. We'll come to all the definitions in detail. So that time we'll answer your question. Okay? Hold on for some time. I'll answer. So including rational and irrational together, we get real numbers, right? And real numbers may, when we include imaginary numbers, I get complex numbers. So that is my whole universe of numbers, right? So natural, whole, integer, rational, real, complex. That is my whole universe of numbers. Okay? Now let's have a look at them one by one. Let's start from back end. Let's start from complex number. So complex number is the largest possible set of numbers. Yes, Anushka, I'm explaining all. Hold on. See, guys, I have just mentioned all the names as of now. just wait for some time. I'm going to explain all of them one by one in detail. So that time, if you have any definition related issues, they will get clear. Okay. All right. So let's start from the back end. That is complex numbers. So what exactly comes into complex number? So complex number as definition, I can see that it comprises of real and imaginary both. Complex number comprises of real and imaginary both, right? So can I say it is A plus BI? This is the real part, this is the imaginary part. Now you will ask me next question, what is I? How do I define I? Let's say I give you any number. चलो एक काम करते हैं. What is 1 square? Tell me what is 1 square? 1. What is minus 1 square? 1. What is 2 square? What is minus 2 square? What is 0 square? 0. What is 1 by 2 square? So that means any square that you are looking up to will always be positive. Can I say? Any square that you are looking up to will always be positive, correct? Except for 0, and 0 square is 0. So can I say no square can be negative? So if I give you one equation, say x square is equal to minus 4, find the value of x. Can you tell me what would be the value of x over here? 2. Are you sure it will be 2? Because I know that 2 square is equal to 4. Minus 2? Sure, because I know minus 2 square is also 4. So nothing. That means if at all I am looking at x square equal to 4, so to find out the value of x, I should look at square root of minus 4. And to look at that square root of minus 4, should I look at the positive side of numbers? No, because positive ka square is positive. Should I look at negative side? No, negative ka square is also positive. So whose square is minus 4? I don't know any such number. So that's when I define a new category of numbers whose square is negative, right? So thus I define, say, I'll say x is equal to root of minus 4, and I define imaginary variable iota, or constant rather, sorry, imaginary constant iota, where iota is equal to under root of minus 1. So x here can be written as 4 into minus 1. So x can be written as 2 into under root minus 1 will be called as I. So this will be plus or minus 2i. Because every square root, there are two roots always. For every square root, there are two roots, positive and negative. So x here becomes plus or minus 2i. Okay? Suryank, I couldn't understand exactly what you want to say, that x2i is equal to 4 matlab. So what I got to know from here is iota is equal to under root minus 1. So if iota is equal to under root minus 1, can you tell me what will be iota square? No, Suryank, it's not the same. Soumya, iota is equal to under root minus 1. Let me write that again. Okay. So I square will be equal to under root minus 1 ka square, that is minus 1. What will be I cube? Can you tell me what will be I cube? Yes, Madhushri, your messages are reaching. Tell me. Yes, Pushkar. See, all of you are giving answers. See, multiple people are giving me answers. So it's possible that your answer is lost somewhere in the track. You yourself can keep a track. If your answer is right, good. If your answer is not correct and you have a doubt, you can let me know. Okay? I cube will be I square into I. Correct? Can I say I cube is equal to I square into I? And I square is minus 1. Minus 1 into I will be equal to minus I. Right? So I cube is equal to minus I. What is I raised to 4? What is I raised to 4? I raised to 4 will be I square into I. I square into I square. Correct? That is minus 1 into minus 1. That is plus 1. What will be I raised to 5? I raised to 5 will be I raised to 4 into I, and I raised to 4 be calculated above is 1. So 1 into I will become I raised to 6, I raised to 4 into I square. That is 1 into I square is minus 1. That is minus 1. I raised to 7 will be what? I raised to 4 into I raised to 3. That is 1 into I raised to 3 we calculated above is minus I. So overall it will be minus I. Correct? Last, what will be I raised to 8? I raised to 8. That will be, won't we be substituting value of minus I? No, we won't be substituting the value of minus I, because after that it will be under root of minus 1 again. See, I don't want that under root sign. Under root my negative seems to be complicated to me. So that's why I don't want to use it. So wherever it will be under root minus, I will use I instead. Okay? Otherwise, the whole purpose of using I will get lost. Okay? Just a second. No, Nihal, there is no further calculation of under root minus 1, because we have initially defined, that's where we started the whole thing. Na? I is equal to under root minus 1, right? Surya, minus of under root of -1, is it equal to under root 1? No, because minus of under root of -1 will be like minus I, and under root 1 is equal to 1, and I and 1 are not equal. So no. I hope that clears your doubt. Okay. Now guys, have a look at the pattern. I is the first term, second is -1, then minus I, then 1, then I -1 minus I, sorry यहाँ पे 1 है, I raised to 4 into I raised to 4, that is 1 into 1, that is 1. So if you observe, I'm getting a pattern over here, that is I -1 minus I1, I -1 minus I1, I -1 minus I1. So this repetitive pattern I need to use to find out various powers of I. Now I -1 minus I1, this is repeating after every 4, correct? It's repeating after every 4. Yeah, sorry guys. No, Richa, actually I was drinking water which got stuck. That's all. Sorry. So based on that, can you try finding out the value of I raised to 1947? So how should I find the, sorry, how should I find the value? I raised to 1947 should be broken down into multiple of 4. So can you tell me which is the closest multiple of 4 to 1947? Closest multiple of 4 to 1947? 1948 is the closest multiple, correct? So can I write it like this? 486 is the, sorry, 486 is the quotient. But I'm not looking at the quotient over here. I'm looking at which is the closest multiple of 4, right? So why 4, Madhushri? Because we checked for I, there is a cycle of 4. I -1 minus I1. So my cycle may, the numbers were repeating after every 4. So can I say I raised to 4 is equal to 1? I raised to 8 is equal to 1. So I raised to any multiple of 4 should be equal to 1. So can I say I raised to 1948 should appear over here? So 1947 should be one step before that. That should be this. Understood, guys? That what I should do is split it up in terms of powers of 4. Split it up in terms of powers of, multiples of 4. And whichever is the closest multiple of 4, put it at the position of 1 and then go ahead or before. Once again, okay. How about we try for a different example now, Ravi? Would that be fine? China, would that be fine? Okay. See, we have already seen there is a pattern. Now let's try some other. I raised to 93. Say I raised to 93. How do I do it? Which is the closest multiple of 4 to 93? 92 is the closest. So can I say it is I raised to 92 plus 1? I raised to 92 plus 1, right? So I raised to 92 should be wherever any multiple of 4 is lying. So I raised to 4 is here, I raised to 8 is here. So all the multiples of 4 are having a value 1. So I raised to 92 should be over here, or I raised to 92 should be over here better. So 93 should be over here. So I raised to 93 ka value should be I, can I say? So because the values are repeating after every 4. So it's like 1, 2, 3, 4, repeat, 1, 2, 3, 4, repeat, 1, 2, 3, 4, and so on. So it's like till 92, it's like 89, 90, 91, 92, repeat, 93, 94, 95, 96, repeat, and so on. So 93 is the first of the cycle, and first of the cycle is this. So my value is I. Clear everyone now? Is everyone with me? Let me know if anyone is having a doubt. Okay? All right. Try next. Sorry, acha, ye nahi kiya. I raised to 202, which is the closest multiple. 200 will be the closest multiple. So let's take 200 over here. So if 200 is here, then 201, 202. Value should be minus 1. Okay. I raised to 111, which is the closest multiple. 108 or 112, right? Say 112. Why not 201? Because Pushkar, is 201 a multiple of 4? I am looking at multiples of 4. See, I'm keeping that as my benchmark. Find out the closest multiple of 4, put it at the position of 1, and then go those many digits forward or those many digits backward as required. For example, if I take closest multiple of 4 over here as 112, so if I take 112 as the closest multiple, then I would say this is 112. So 111 would be one step behind this, that is this. So I raised to 111 should be minus I. Clear? Clear, guys? Is everyone with me? Option will be having I, yes, of course. Options will be in terms of I. And now a little bit more on complex numbers. What number goes well with 5 plus 3i? The number must be 5 minus 3i, which is called as its conjugate. Now, what's the relevance of this conjugate? See, if I add these two, if I add a number with its conjugate, What do I get? China, yes, we have to always consider with respect to number 4 because the cyclicity is of 4. That means the values of I are repeating after every fourth power. So that's why it's important to look at the multiple of 4, closest multiple of 4. Okay? So what is conjugate? Conjugate is basically changing the middle sign. So 5 plus 3i is the original number. Then its conjugate 5 minus 3i will be, sorry, 5 minus 3i will be called as its conjugate. Okay? So what's the relevance? If you add these two, then 3i will get cancelled. 5 plus 5 will become 10. That's only the real part. Or if you multiply them, what do you get? You multiply them, what do you get? So I get 5 plus 3i, 5 minus 3i. That is a plus b, a minus b. And a plus b, a minus b, a plus b, a minus b is a square minus b square. All of us know this. So a square minus b square, sorry, a square minus b square, 5 square 25 minus 3i the whole square, that is 9i square. So 25 minus 9i square. What is the value of I square? I square is minus 1. So 25 minus 9 into minus 1. That's 25 plus 9. That is 34. Right? Correct? So either you add them or you multiply them, you will always get a real number only. Like this number right now is a complex number because it includes imaginary part as well. But when you add them or multiply them, that is the number and its conjugate, you will always get a pure real number. Imaginary part will get removed. Okay? Suryank, you will see in examples. There will be a few examples wherein you will understand this. Okay? What do we mean by number goes well with? Number goes well with is, see, we are not so comfortable with using imaginary numbers. So we always want to convert it to real. And our best shot in converting it into real will be the conjugate. Because as I can observe, addition with conjugate or multiplication with conjugate is resulting in a real number. So that's how I can say number that goes well with. Okay? Can we take square root of imaginary number? That square root of imaginary number? Not really, because square root of I. No, it doesn't make sense. Going for square root of I doesn't make sense. Because, see, let me tell you. So you want to go for square root of I? Can I say square root of I will be equal to square root of I raised to maybe say 5? Yeah, so 5 nahi. Let's try taking a different number. Okay, let me write I is equal to under root minus 1. So square root of I will be equal to minus 1 raised to half, bracket raised to half. So that's minus 1 raised to 1 by 4. So minus 1 raised to 1 by 4, whose fourth power is minus 1. Not really, nahi. In terms of complex number, it won't be defined. So it doesn't make sense to take square root of imaginary. नहीं आएगा. ठीक है? All right. Next. Next is rational and irrational numbers. So in case of rational and irrational numbers, what is my definition of rational number? Does anyone know what's my definition of rational? Which numbers can I call as rational? Okay. Any number that can be represented in the P by Q form where Q is not equal to 0. Absolutely right. That is my definition of rational numbers. That any number that can be represented in P by Q form where Q is not equal to 0 and P and Q are integers. And P and Q are integers. Okay? So that's my definition of rational number. But if you observe, if you remember from the first slide, we said that while we are going from integers to the rationals, there were two things which were not there earlier and now I should start using. Number one was fraction and number two was, what was the other thing? Okay. Yes, the other thing was decimals. Yes, correct. Other thing was decimals. So if we start using decimals now, say I'll give you an example. Say 1.2. This could be one decimal, or say 1.22. This could be another decimal, or say 1.22341342598 and so on. So there can be three types of decimals. What would you call number one? The first one, 1.2. What do you call it? Terminating decimal. Second one would be called as recurring decimal. And the third one would be called as non-terminating, non-recurring decimal. Correct? Terminating, recurring, and non-terminating, non-recurring. Right? So which of these three types would you call as rational? Important question. Which of these three types would you call as rational? Type 1 and type 2. Okay. So in that case, guys, acha, for those who are giving me answer as type 1 and type 2, can you represent type 1 and type 2 in the P by Q form? Because any number that I should call as rational should follow this rule and must be able to, we must be able to write it in P by Q form. So can you tell me how can I write it in P by Q form? So first one is very simple, 12 by 10 or 6 by 5. Yes. What about second one? This one is critical. Yes, Vaibhav, that is correct. Suryank, 123 by 100 would be 1.23, not 1.2222. Okay, Aditya. Yes, that is correct. Sorry, Vaibhav. No, your answer is slightly wrong. Small calculation mistake, probably. Check once again. Madhushri, not possible. So that means, Madhushri, do you mean to say that only type 1 is rational and 2 and 3 are not rationals? And then whatever is not rational should be irrational then? Is that what you want to say? Okay, so okay, there are many people again out there saying that only type 1 is rational, 2 and 3 are not. Okay. Yes, Vaibhav, that is correct now. So let me tell you, type 1 and type 2, type 1 and type 2, both of them are considered to be rationals. Type 1 and type 2, both of them are considered to be rationals. Type 3 is not. And whatever is not a rational must be irrational. Type 1 is simple, how we can write it as P by Q form. But let's look at type 2. Let's look at type 2. How can we write it in P by Q form? See, terminating is like this. Recurring is like this. So we can denote it like this, 0.3 bar. But that's just a way of denotion. That's it, nothing else. So in case I have to write it in fraction form, I need to write something like this. But how can I write it? So let's take this for an example, 0.34 bar. So question 1, how many digits are repeating? 2 digits. If 2 digits are repeating, so we will multiply by 10 square. We will multiply by 10 square. So let's say x is equal to 0.343434 and dot dot dot. It doesn't end there, it continues. So when you multiply this by 100, what do you get? 100x is equal to 34.34343434. When you multiply this by 100, your decimal would shift to the 2 digits, right? Correct? So when your decimal point shifts to the 2-digit rightwards, so that time it will become 34.3434. Take a difference between the two. Take a difference between the two. This thing will entirely get cancelled out. And since this thing is getting cancelled out, so I get 99x is equal to 34. 99x is equal to 34. So x is equal to 34 by 99. So similarly, if I say 1.22222, that is 1.2 bar. So how many digits are repeating over here? How many digits are repeating? Only one digit is repeating. So by what number should I multiply this? If only one digit is repeating, then I should multiply by 10, correct? So 10x is equal to 12.222. 12 point या तो 12.2 बार लिख देते हैं, ठीक है? Take a difference. So 9x is equal to 11. X is equal to 11 upon 9. China, it is a difference between the two. Let's say this is equation number 1, this is equation number 2, and you are taking a difference between the two. Okay? So 100x minus x would become 99x. Clear, everyone? Why 11? Because 12 minus 1 is 11. So can you tell me how can I write it in P by Q form? So first one is very simple, 12 by 10 or 6 by 5. Yes. What about second one? This one is critical. Yes, Vaibhav, that is correct. Suryank, 123 by 100 would be 1.23, not 1.2222. Okay, Aditya. Yes, that is correct. Sorry, Vaibhav. No, your answer is slightly wrong. Small calculation mistake, probably. Check once again. Madhushri, not possible. So that means, Madhushri, do you mean to say that only type 1 is rational and 2 and 3 are not rationals? And then whatever is not rational should be irrational then? Is that what you want to say? Okay, so okay, there are many people again out there saying that only type 1 is rational, 2 and 3 are not. Okay. Yes, Vaibhav, that is correct now. So let me tell you, type 1 and type 2, type 1 and type 2, both of them are considered to be rationals. Type 1 and type 2, both of them are considered to be rationals. Type 3 is not. And whatever is not irrational must be irrational. Type 1 is simple, how we can write it as P by Q form. But let's look at type 2. Let's look at type 2. How can we write it in P by Q form? See, terminating is like this. Recurring is like this. So we can denote it like this, 0.3 bar. But that's just a way of denotion. That's it, nothing else. So in case I have to write it in fraction form, I need to write something like this. But how can I write it? So let's take this for an example, 0.34 bar. So question 1, how many digits are repeating? 2 digits. If 2 digits are repeating, so we will multiply by 10 square. We will multiply by 10 square. So let's say x is equal to 0.343434 and dot dot dot. It doesn't end there, it continues. So when you multiply this by 100, what do you get? 100x is equal to 34.34343434. When you multiply this by 100, your decimal would shift to the 2 digits right. Correct? So when your decimal point shifts to the 2-digit rightwards, so that time it will become 34.3434. Take a difference between the two. Take a difference between the two. This thing will entirely get cancelled out. And since this thing is getting cancelled out, so I get 99x is equal to 34. 99x is equal to 34. So x is equal to 34 by 99. So similarly, if I say 1.22222, that is 1.2 bar. So how many digits are repeating over here? How many digits are repeating? Only one digit is repeating. So by what number should I multiply this? If only one digit is repeating, then I should multiply by 10, correct? So 10x is equal to 12.222. 12 या तो 12.2 बार लिख देते हैं, ठीक है? Take a difference. So 9x is equal to 11. X is equal to 11 upon 9. Shaina, it is a difference between the two. Let's say this is equation number 1, this is equation number 2, and you are taking a difference between the two. Okay? So 100x minus x would become 99x. Clear, everyone? Why 11? Because 12 minus 1 is 11. Nitish, I am taking a difference. So 10x minus x became 9x, and 12.2 bar minus 1.2 bar will give you 11, right? Next, shortcut trick to calculate this. Harsh, yes, there is a shortcut trick to calculate this. So let's take an example. Or better, chalo, you guys give me an example. You guys give me an example that I will convert and show it to you. Recurring, of course, I need recurring wala. 3.123, ठीक है. Let's take this 3.123, and so on. Let's do this one together. So let's write it as 3 plus 0.123, or let's write chalo 3 plus 0.123 bar. So if there are 3 digits recurring, then division must be by 999. If there are 3 digits recurring, then division must be by 999. So I will write it as 3 plus 123 by 999. So what you do is you separate out the integer, you separate out the entire thing and the repeating part. Repeating part, you directly divide by 9 or 99 or 999, depending on number of digits repeating. And other part you write down as it is and then add the two of them. Clear? So now you can cross multiply, add them, and get the net fraction, whatever it is. Right? So it will be 3120, correct. 3120 upon 999. Okay? Is everyone with me? All right. Vaibhav, 9.999 would be simple. So I will shift the decimal by 1. So it will be like x equal to 9.99. If I shift it by 1, say 10x equal to 99.999 and so on. And if I take a difference, then 9x will become 99 minus 9, that is 90. That's it. So x, acha. Okay, here it is coming out to be exact 10 because it is coming out to be approximation. Okay. Okay, I'll tell you how it is coming out to be. See, in general, can you tell me what is 1 by 9? What is 1 by 9? Can you tell me? Zero 0.111, correct? So if I take such 9 1 by 9s, what do I get? 0.111, 0.111, 0.111. 9 times I will get. So if I add all of them, what should I get? 0.9999 and so on. But I'm adding this 9 times. Let me add this also 9 times. So 1 by 9, 1 by 9, 1 by 9, 9 times. So that's like 9 into 1 by 9. So when I do the cancellation, I get a 1. Correct? So in that case, it comes out to be something like this. That is because it is approximation. Because it is approximation. Okay. 0.99999 is approximately equal to 1. So whenever you are converting it into a fraction like this, we are approximating. Some part of it is getting approximated. Yeah, in general, yes. Soumya, 0.46 bar can be written directly as 46 by 99. Yes, Vaibhav. It tends to be a very small part. It's like after infinite decimals, there will be that small part which is creating a difference. Okay. So 0.46 is written as this, maybe then 0.245 bar can be written as directly 245 by 999. And instead of 0 point, if I make it 8 point, then it should be 8 plus this thing. Clear now? The shortcut part is clear. 64.501501,501. So that can be written as 64 plus 501 by 999. The rest of the calculation you can do. Okay? Madhushri 3.23. Okay. How to do for such a thing? That's something like 3.23333 dot dot dot. Just remember the basic logic. What was the basic logic that I said? How many digits are repeating? Jitne digits repeating, that many, sorry, that by that much power of 10, I have to multiply. So if I say x equal to 3.23333, then I multiply by 10 and make it 10x equal to 32.3333. So after this, all the threes will get cancelled when I take a difference. So I get 9x is equal to 29. Sorry, itna hoga 3 minus, that's 29, and 0.3 minus 0.2, 29.1. Correct? 29.1 will be the difference. So x will become 29.1 upon 9. So in case you want to convert it into integer by integer format, then you can write it as 291 upon 90. Understood? Clear, everyone? Soumya, even if we get a decimal, it can be converted to integer. Shortcut, yeah, shortcut may not work in this case. See, again, shortcut can work, but you have to practice it a lot. Yes, practice it a lot so that you get very much accustomed with it. See, it can be done like this. 3.23 bar. So what I'll do, 3.2 plus 0.03 bar. So had it been 0.3 bar, I would have written 3 by 9. But since it is 0.03 bar, I would write it as 3 by 90 instead of 9. So 3.2 can be written as 32 by 10. And then you can do it. So this would be the shortcut. Why 90? Because there is additional 0 after the decimal. That's why 90 instead of 9. See, it's not repeating like 03, 03, 03. Aisa nahi hai. It's 0, 3, 3, 3, 3, 3. So that means there should be only 1 in the denominator. But since it is not 0.33 direct, it is 0.03. Additional 0 is there. So to compensate with that 0, I need to add 1 0 in the denominator also. Why not 99? Because it is not 0303. It is 0333. Understood the difference between the two, Surya? So had it been like 0.3333, I would have written directly 3 by 9. For something like this, I have to write 3 by 90. And for something like this, I would have to write 3 by 99. Has everyone understood the difference between all of them? Suryank, why don't you give it a try now and then tell me later? Okay? So these are few examples. We have seen enough examples now, so I'm sure all of you can manage these. If not, I would still suggest that you guys give it a try once. And if you don't get it, then let me know in the next session. Okay? That time I'll explain again. But before you practice, it doesn't make sense to again go for multiple examples. Okay? 3 by 99. Rahul, when it was 030303, so that time two digits are repeating. So shortcut was the number of digits you have repeating, those many number of nines should be there in the denominator, and the numerator is like 03. Had it been 1313, so you would have written 13 by 99. So here it is 0303. So you write down 03 by 99. That is 3 by 99. Done? Clear, hai, Rahul? No, why multiply by 10? 3 by 99, that's it. See, the repeating, see, it's like repeating part starts immediately after a zero, or repeating part starts one step after a zero. That's the difference. So this becomes 3 by 99 and this becomes 3 by 90. Does my repeating part starts immediately after zero decimal, or does it start one step after the decimal? There it makes a difference. Okay? So Pushkar, isn't that this thing, isn't it very much similar like this? Same thing. Third one. Aditya, same thing we are doing again. Keep 0.6 bar can be written as 6 by 9 directly, shortcut. And 6 by 9 is 2 by 3. See, what was the shortcut? The number of digits which are repeating, those many number of nines you should have in the denominator. That's it. So if there is only single digit repeating, so only 9 will be there in denominator. So 6 by 9. So for this one, for example, only one digit is repeating. So it should be 5 plus 3 by 9. And then simplify this. Okay. Guys, why don't we do one thing? You guys give it a try once on your own. And in case you do not get this, then ask me the next time in the next session. So that time I will explain. Because otherwise, see, all of you will have different examples and our entire session would be gone in this only. So you give it a try on your own once. If you don't get it, let me know next time. I'll do it. Okay? So let's start segregating the numbers now. So can you tell me that the numbers that I have mentioned on screen belong to which category? The first one belongs to first one belongs to natural number, guys, because cube root of 8 is very much possible. Cube root of 8 is equal to 2, and 2 is a natural number. Okay? Second, square root of negative number, that is imaginary, and imaginary is not mentioned as a category over here, so I should say complex. No, Madhushri. Natural plus whole is integer. They are in a sequence over here. Two by 13, rational. 3 pi, irrational. Okay, so now coming to your coming to your definition of pi. So someone was saying, sir, how come pi is irrational? So what is the value of pi? All the values that you just mentioned, 22 by 7 or 3.14 or any of such things, all these values of pi are approximations. The actual value is 3.14159 and so on. This doesn't end, this doesn't recur. There is no fixed pattern. The values do not repeat after a certain point in time. They just randomly go on. And that is my definition of irrational number, that the number should be neither terminating nor recurring, right? So that's why pi is irrational. Okay? Very good, Pushkar. And since it is irrational, I can call it as real because irrational is not mentioned as a category. So I'll say natural or whole or integer or rational, real, complex. These are mentioned as categories. So I will go for the broader one. Okay. Priyesh, 7.0 is integer or natural. So whenever it's 7.0, you write it as 7 only. And 7 is a natural, so it becomes natural. Including a decimal and then writing down zeros doesn't really change the fact that it is 7. Okay? 22 by 7 is approximation, yes. China, pi is irrational. By definition, pi is irrational because the value of pi is 3.14159 and dot dot dot. So it's like it doesn't end, neither it recurs. It goes on up to infinite digits without repeating the pattern. So that's why pi is irrational. And when 3 is multiplied by pi, that also is irrational. And rational plus irrational put together is real. So 3 pi will call it as real. Okay? Aditya, yes, I said 22 by 7 is an approximation. Yes. So let's try next one. Minus 28 by 4, that's minus 7. And minus 7 is integer. 0 is whole. 4i minus something, that is complex. And 0.0011. This would be rational, guys. Rational. This would be rational because it is ending at 0.0011. It is ending. It is not dot 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 after that. So I can write it as something like this, right? So rational. Try this. Nihal, the question is changed. Check the question. So let's see. I square minus 1, I cube minus I raised to 82, I raised to 82 will be minus 1 because it's a cycle of 4. Closest multiple is 80. So 2 after 80, that means I minus 1 minus I 1, 1 that is 80. Then 2 after that. So next cycle में 2, I and minus 1. And 2 plus 3i, 2 minus 3i, that is 4 minus 9i square. That is 4 minus minus 9, that is 4 plus 9, that is 13. Everyone clear with this? Hope no one is having a doubt. Good. Try this one again. let's see the first one. The first one is rational because it is in the normal P by Q form. The second one is also rational. Now this, some of you may have failed over here. Now how can this be a rational, you might ask, because I don't see it in the integer by integer form. So what? I can convert it in integer by integer form. If I have to shift the numerator decimal by 4 places, that is something like this. Can I write it like this, integer by integer format? Correct? So that's why the second one is rational. Okay? Third, third is not rational. Third should actually be natural. Because 54 by 2.7, if you calculate, comes out to be 20. It comes out to be 20, so answer should be natural. And last one is real because root 31 is irrational. So root 31 by 12 is also irrational, that is real. Okay? Natural can also be called as integer. Yes, okay, that's a good point, Rahul. See, natural numbers contain what? 1, 2, 3, 4, 5. Whole number contain what? 0 and 1, 2, 3, 4, 5. So if I say this is my set of natural numbers, then 0 includes everything. Sorry, whole numbers include everything that is a natural, and additionally it includes a 0. Similarly, if I talk about integers, then everything that's a whole number is already a part of integers, plus integers mein there are negatives. Similarly, can I say rationals are over here? Similarly, can I say real numbers are over here? And similarly, encompassing the real numbers, can I say complex numbers are there? Correct? So any number which is a natural number is also whole, also integer, also rational, also real, also complex. Any integer is real, rational, complex. Any rational is real and complex. But any rational is not necessarily integer. A rational may or may not be integer, but a rational is definitely real. Getting the difference between the two? So if I say my rational number is say 12 by 1, then this will become a natural number. But the moment I make it 12 by say 13, it's no more natural, but it is still real. It is still complex. So now you will ask how 12 by 13 is complex. So 12 by 13 can be written as 12 by 13 plus 0i. So any natural number, whole number, integer, or any real number for that matter can be written like this in complex format. A plus bi, where b is equal to 0 works. Okay? Nihal, yes, any imperfect root is irrational. So clear, everyone? So here, whenever I'm answering, I need to answer the smallest possible circle. Because in general, so I can call this also complex, 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 complex. Everything will become complex. My answer will always be complex. But that's not what I want. So try to find out the smallest possible circle. Larger circles are automatically included. Okay? Try this. So let's check the answers. First one is real, second one is complex, third one is complex, and fourth one integer. No, how can it be integer? Square root of 6. Is it a perfect square? No, right? This is also real because positive irrational or negative irrational, both are real, right? So as long as the negative sign is not inside the root, everything is real. Okay? Clear, everyone? Can we go to next question? Okay. So next classification is there again. So we have checked up till rationals. Now rationals may, let's split it into fractions. And let's look at classification of fractions a little bit more. Okay. Soumya, nothing to calculate over there. Whenever you see negative sign inside the root, it will be called as complex. Okay. But those were rational, Priyesh, for which one? Irrational? No. Irrationals are real. Irrationals cannot have negative number inside the root. Negative number inside the root. Okay? Very good question. So classification of fractions. Fraction means part of a whole. Suppose you have a pizza with 8 slices and someone asks you for 2. So basically no problem. So you will give 2 out of the 8. 2 out of 8. 2 by 8. That is, you are giving 1/4 of the pizza. So no problem. But let's say you have a pizza with 8 slices and someone is asking you to provide 11. A bit awkward, right? So that's why this first fraction of 2 by 8 is called as a proper fraction and 11 by 8 is called as improper fraction. Something that we find awkward, we call it as improper. Okay? So in mathematical terms, whenever your numerator is smaller than denominator, repeating, whenever numerator is smaller than denominator, it is called as proper fraction. And whenever numerator is greater than denominator, it is called as improper fraction. Okay? All right. Next. Formally a proper fraction is, ये definition हमने देख लिया already. So let's try to convert them into each other's. So 5 integer 3 by 7. Let's try to convert it into improper fraction. By the way, this one is called as mixed fraction. This one is called as mixed fraction. To convert any mixed fraction into improper, what we do? We multiply 7 with a 5, we get a 35. We add the numerator and divide by the denominator. 38 by 7. Everyone knows this. No issue in this. Right? All mixed fractions are improper. Yes. Yes, Nihal. Necessarily, all the mixed fractions will be improper and all the improper fractions can be written as mixed. Okay. Try this. Convert this into improper fraction. So I know how to do this. This is 4.3 bar. Do you remember the trick? What do? We write it like 4 plus 0.3 bar. 4 plus 0.3 bar. That is 4 plus 3 by 9. That is 4 plus 1 by 3. So that is 12 plus 1, 13 by 3. ठीक है? Right? Twelve by 7 into a mixed fraction. 12 by 7 into a mixed fraction. So how do I convert it? I divide 12 by 7 actually, write down the quotient over here and remainder over here and denominator as it is. One integer 5 by 7. That's how I write a mixed fraction. Correct? Six eight six eight six eight six eight into a proper fraction. Straight away, can you tell me? It will be 68 by 99. Yes, that's it. Straightforward. Okay? Clear? Can we go to next? Now, positive into positive. Now, see, now we have learned about the fractions. So now let's look at the next part, that is integers. So integers basically contain positives and negatives. So from here, my concept of positive and negative start. So let me check some different possibilities. Positive into positive is what? Positive for sure. Negative into negative. How about negative into negative? That is also positive, right? Negative into positive, that's negative. And positive plus positive, positive. Negative plus negative, negative plus negative. Think carefully, guys. It's like -3 plus -4. So that's the -7. That is negative. Negative plus positive, negative plus positive. Very good. It depends. It depends on which one is greater. So it's like -3 plus 4 positive, but -5 plus 4 negative. So it depends on who is greater in terms of magnitude. Okay? So let's try an example. Say positive into positive plus negative into negative minus negative into positive. Can you tell me overall kya hoga? What will it be overall? Positive into positive. Let's look at the first part. What will it be? Positive, then plus. Negative into negative is what? That is also positive. And then negative into positive is what? Negative into positive is negative, but I have a minus sign outside. So it's like minus negative. So can I say it's like positive, positive and minus negative will again become positive? So overall, can I say it must be positive? Everyone agrees? Okay. All right. Moving on to next. Whenever you face any difficulty, please let me know, guys. Stop me right there and ask. Okay. So next part is very important. That is comparison of fractions. We often find situations, especially in calculative DI, where we need to estimate which of a given pair of fractions is larger, and that too we have to do it quickly. So for which we had seen, sorry, just a second, guys. Yeah. Pushkar, yes, it's very important to have a good foundation. Otherwise, if you don't get that right start, then the whole building will collapse. So we will go very slow in the initial few sessions. Okay. So yes, three rules. Absolutely right, Nihal. We have seen three rules of comparison of fraction. If you guys remember from our first session, basics of calculation, for those who were with us that time, I'll repeat the rules, don't worry. So the rules are like, the rules are, by the way, you need to notice that the rules are as per the ease of application and not as per the importance. That means rule number one is more important, rule number two is less important, nothing like that. It depends on the ease of application. How easily can I apply that rule? So rule number one, that is most easily applicable. See, this is like, number one, you have to check whether my difference in the numerator and denominator is same. Examples. So let's say 4 by 7 and 5 by 8. My difference between numerator and denominator is same. Yes, number one. Number two, second question that you should ask is whether the fractions are proper or improper. How about these fractions? Are they proper or improper? They are proper. So whenever I'm talking about proper fractions, I need to remember that proper fractions behave properly. Proper fractions behave properly. So the larger looking numbers should obviously be larger. The numbers which appear to be larger in size are actually larger. That's the rule for proper. And improper behave improperly. So if they are improper numbers, then obviously they would behave improperly. That is, larger the number, smaller is the fraction. For example, in this case, question number one, is my difference between numerator and denominator same? Yes, it's a difference of 3 and a 3. Question number two, proper or improper? Improper. Improper behaves improperly. That is, larger the number, smaller the fraction. So 20 by 17 is smaller than 16 by 13. So this one is greater. Clear? Understood rule number one? So first question, check the difference between numerator and denominator. Is it same? Second question, check if the fractions are proper or improper. And then proper behaves properly, improper behaves improperly. Okay? Next, what's the second thing that I can do? Rule number two is when I can make numerator or denominator easily equal. When I can make numerator or denominator easily equal. What can I do then? So for example, something like this. say you have to compare 5 by 7 with 16 by 21. So I will convert 5 by 7 into 15 by 21 by multiplying numerator and denominator by 3. Now I can check. So I told you for this, you have to remember the cake logic. That is, denominator is the number of pieces in which I'm cutting the cake, and numerator is the size in which, size of the cake. Numerator is the size of cake, and denominator is the number of pieces in which I'm going to cut the cake. So if you observe here, my number of pieces are same. So larger the cake size, larger will be my portion size. Correct? So there are two cakes, one of size 15, one of size 16, both being cut into 21 pieces. The one which is being cut into, the one which has a larger size, that is 16, must be the larger one. Similarly, for this one, I can convert it like this, 36 by 21 and 36 by 22. See, 12 by 7 can be multiplied by 3 and make it 36 by 21. And 18 by 11 can be written down as 36 by 22 by multiplying by 2. Now both are equal size cakes. One is cut into 21 pieces, other one is being cut into 22 pieces. So the one which is being cut into 21 pieces should have a larger portion size. Lesser my number of pieces, larger should be the portion size. Correct? So that is my rule number 2. And rule number 3, when neither rule 1 or nor rule 2 applies, or you can apply rule 3 even when rule 1 or rule 2 is applicable. That time also you can apply rule number 3 because it's a generic rule. And what does it say? Simply cross multiply. Example, 5 by 7 and 8 by 11. So what you will do over here, keep the numerators on respective sides, switch the side of denominator. Who is greater in these two? 5 into 11 is greater or 8 into 7 is greater? Who is greater in these two? Eight into 7 is greater, so 8 by 11 is greater. That's it. Understood? This is how I can compare fractions. Let's try the second one also, 19 by 13 and 13 by 9. Keep the numerators on respective sides. Shift the denominator. So this one is 171, this one is 169, this one is greater, greater, greater. Understood? Understood the comparison between the two? What if there are decimal points in the numerator? Still cross multiplication is valid. Rahul, cross multiplication is still valid. Okay? Next. Rather than trying examples over here, let's try real-time examples. Just a second. Just a second, guys. Okay, so I have given you 6 questions, and I am giving you 3 minutes for this. Right? 6 questions, 3 minutes. Go for it. Done, guys? Let's see. Let's have a look at these questions one by one. First one, I already gave it to you guys. That was 13 by 16 is greater, because rule number 1 we can apply over there. Second one, again rule number 1 can be applied, but this is improper fraction. Since improper fraction, so larger the number, smaller the fraction. So 13 by 10 becomes smaller. So 11 by 8 becomes larger. Right? Next one, I can double this and write it as 14 by 18. Then cake logic. Size 14 cakes are there. One is being cut into 19 pieces. Another one is being cut into 18 pieces. So the one which is being cut into 18 pieces would have a larger piece of cake. Correct? So this one. Then 3 by 14 and 5 by 23. So 23 3s are 69, 14 5s are 70. Rule number 3, 70 is greater, so this one is greater. Remember, you have to keep the numerators on respective sides. Yeah, or you can use rule number 2 and make the numerator same, that 15 and 15. Chalega. Next. Rule number 1 would be applicable again. Difference between numerator and denominator is consistent. Right? So I would say that since they are proper fractions, so larger the number, larger the fraction. And last one. Which rule for the last one? Which rule for the last one? Improper versus proper. Yes. No rule shall be applied. However, first one is improper, that is greater than 1. Second one is proper, that is less than 1. So greater than 1 will always be right. Always be greater. Okay? Pushkar, the method doesn't matter. Even if you cross multiply, you can still get the correct answer. See, if you do the second one by cross multiplication, it will be 11 into 10, that's 110. 13 into 8, that's 104. Still 110 is greater, so 11 by 8 is greater, you can see. So method is not important. All the methods are applicable everywhere. In C, still 14 into 9, that's 126. And 19 into 7, that's 133. So this one is greater. See, same answer. So your method is not important. Okay? All right. So next one. Let's talk about classifying numbers in depth. Dealing with 0. Say I add 0 to something, then my number remains same, no change. Subtract 0, no change. Multiply by 0, number becomes 0. And divide by 0, not possible. Undetermined, not defined. Yes. Okay? Now 0 is the difference between the natural numbers, also described as positive integers. So, 0 is the difference between natural numbers and whole numbers. Natural numbers are 1, 2, 3, 4. Whole numbers are 0, 1, 2, 3, 4. Okay. And by the way, natural numbers are called as positive integers because integer contains negative integers, positive integers, and a 0. So positive integers are 1, 2, 3, 4, 5. That is same as natural numbers. Correct? So by that logic, whole numbers, that means out of the integer part, I do not want negatives. 0 is okay, positive is okay. So that means non-negative, can I say? So can I say whole numbers are nothing but non-negative integers and natural numbers are nothing but positive integers? Understood? Samat, 0 upon something is infinite. No, 0 upon something will be 0. See, again, imagine your fraction to be like a cake. Remember the cake logic. So there is a size 0 cake, which say you are splitting into 5 persons. There is no cake to distribute with. So how much each of them will get? 0, 0, 0, 0, and 0. There is no cake. So 0 upon anything is 0. Understood? Now 0 upon 0 is slightly different case. When I'm talking about 0 upon 0, it's like I don't have a cake which I have to distribute in 0 number of people. I don't know how much can each of them get. It all gets into imaginary mode. See, it's very simple to give one piece of cake to one person, but zero piece of cake to zero person, I don't know. First problem, I don't have anything to start with, and second problem, I don't know how to distribute it. Sure, Nihal, ask Siri. So I don't know. You will get some funny answers probably. Later on, you can share it with me. All right. Subdividing natural numbers. So natural numbers are 1, 2, 3, 4, 5. So can you tell me how can I subdivide or categorize natural numbers? What would be my possible categories? Yes. So it's like, sorry, I can distribute it in odd or even. I can distribute it in prime or composite. So most useful, let's talk about odd or even. How do I define even odd? Anything that is divisible by 2 is even. Anything that is not divisible by 2 is odd. And second way is prime composite. So how do I define a prime number and how do I define a composite number? To define a prime number, what I need is, say, let's first अच्छा ठीक है उसके पहले एक बार even odd. Let's do even odd first and then we'll move on to prime composite. So how do I identify even number? Anything that is divisible by 2. Or last digit should be 24680. That's even. And a last digit 13579 will be odd, obviously. Now, the definition is normally applied to only natural numbers, but it can be extended to integers in general. That is like -1, -3, -5 are odd, and -2, -4, -6, -8 are even. The definition can be extended, but by default, the definition is only for natural numbers. We extend it as per our convenience. Okay? So let's talk about some behavior of even and odd. So what is even plus odd? Sorry, even plus even, my bad. Even plus even. You can take an example, say 2 plus 4, that is 6, that is even. Even plus, odd plus odd. That is also even, say 1 plus 3, that is 4, so even. Odd plus even. Odd plus even becomes odd, correct? Odd plus even becomes odd. So, second, odd number of odds will give you odd sum. For example, say 5 odds. That's odd, 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 odd. This becomes even. This becomes even. This stays odd. So even plus even becomes even, and even plus odd will become odd. Right? So remember this always, that odd number of odds will add up to odd. And even number of odds will add up to even then. Okay. Then even into even is what? Even into even is even. Odd into odd. Odd into odd. Odd. Odd into even. Even. Odd into even is even. So even into even will give product even. Sorry, एक काम करते हैं. Let's do some additional things. Say even raised to even will be what? ये तो normal था सब. Now tell me this. Even raised to even. Even raised to odd. Example ले लो चाहिए तो. Even is 4 raised to odd, that is say 3. 4 raised to 3. That is even. Odd raised to odd. And even raised to odd raised to even. It will be odd. Yes. Okay. So if you observe carefully, I can say here that even ka any power will always be even, odd ka any power will always be odd. Correct? Even ka any power will always be even, and odd ka any power will always be odd. Okay. Another important point over here, the only time I get odd product is when I'm multiplying odd with a odd. So that means if I say, for example, product of 10 numbers is odd, then all 10 of them have to be odd compulsorily. Because if even a single even number gets in, then it will make the whole multiplication even. So if I have a product which is odd, then all the numbers in my product have to be compulsorily odd. With me? With me, everyone? Okay, good. So let's answer these questions. Even plus odd is, even plus odd is even. Is it true or false? Right? True or false? It is true. Because odd plus odd becomes even plus even becomes even. So it is true. Next, even into odd into even into odd is even. Okay? This one is also true because, as I said, even number in a multiplication makes the whole multiplication even. Correct? Next, even plus odd into even plus odd. That is odd plus, even plus odd is odd. Even plus odd is odd. So it becomes odd into odd. Answer should be odd. It is mentioned as even. So this statement is false. Very good. Next. Positive plus negative is equal to positive. Positive plus negative is equal to positive. True or false? It depends, cannot be determined. Correct, because it depends on the sign of that negative number. It can be like 10, 10 minus 1, or it can be like 1, 1 minus 100. So cannot be determined. CBD. Yes. Next. Positive into negative is equal to positive. True or false? True or false? True. Because negative into negative will become positive, and then 3 positives will multiply into a positive. So true. Next one, try this. For those who are saying cannot be determined, you guys are forgetting a small part over here, that it is minus of negative. So minus of negative will become positive, right? No, it doesn't depend. Minus of negative will always become positive. So positive into positive is positive. Negative into negative is positive. Minus of negative is also positive. So all the three positives will add up to positive surely. Okay? So true, yes. Understood, everyone? All right. Next one. All fractions can be written as mixed fractions. Yes, no. No, all fractions cannot be written as mixed fractions. Only the improper ones can be written as mixed fractions. Only the improper ones. The one where your numerator is greater. Because mixed fraction involves a quotient, remainder, and divisor format. So to have that quotient, my numerator must be greater. Otherwise, if numerator is smaller, my quotient will always become 0. Okay. Next, all recurring decimals can be written in a rational format. Definitely, yes, it's true. Because we did entire exercise on that, writing down all the recurring like 1.222, 3.2333. We did that exercise to write down all of them in a fraction format, and anything that is in a fraction format is rational. So whenever I am able to write it in P by Q format, it is rational, right? So true. Let's try next type of comparison now. So next type of comparison is prime or composite numbers. So here, do you know the definition of prime number? Which number do I call as prime number? A number which is divisible by only one and itself. Number which is divisible by only and only one and itself. That's it. Correct? So that number is called as prime number, and a number which is divisible by at least one more number other than one and itself will be called as composite. So how many prime numbers are there between 1 to 100? Can you tell me? How many prime numbers are there between 1 to 100? 57. Is that a random guess or a random prime number? I want total number of prime numbers in between 1 to 100. Yes, there are. No, not more than 50. How can it be more than 101? Rakshit, if I'm asking from 1 to 100, how can it be 999? So there are 25 prime numbers between 1 to 100. Let's list them down. So it's like 2, 3, 5, 7, 11, 13, 17, 19, 23, 29. After this, let's count together. Chalo. 29 के बाद 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, after 73, 79, then 83, then 89, and last one is 97. Okay, so you can check. 87, no, Madhushri, 87 is 29 threes are. Okay. All right. Yes, yes, correct, Pushkar. The only important point to be noted over here is 2 is the only even prime number. 2 is the only even prime number. Correct. All others are odd. Yes, correct. Sorry, all composite numbers are odd numbers. No, all composite numbers, how can they be odd numbers? See, for example, 4. 4 is a composite number and it is even. Okay, Nihal, 1. 1 is a special number which is neither even, neither composite nor prime. Rest every number is either prime or composite. Other than 1, every number is either prime or composite. 1 is neither. Okay. China, yes, all primes are odd numbers except for 2. 2 is the only even prime number. Other than that, every prime number is odd. Okay? All right. But these are the only prime numbers between 1 to 100. What if I ask you to find out a prime number which is, say, more than 300, more than 400 and all? How do I find out? If I have to find for a larger, say 301, for example, I have to check for 301. How do I check them? Will I go on by dividing every number till n? For example, to check if if 301 is divisible by any number or not, what should I do? Should I try all the numbers till 301, including 100, 101, 102, 103, all the numbers? Definitely no. Then all the prime numbers, 2, 3, 5, 7, 11, 13, 17, 19. But till what should I go? Up till 301. I don't know how many prime numbers are there above 100. How can I go up till 301? So then what should I do? These are not the ways because I don't know any prime number which is greater than 100. So the shortcut method over here is every prime number which is less than root n, approximately less than root n, right? Example, say 301. So if I check approximate square root of 301, what will that be? Thanks, Shaina. What will be the approximate square root? Near about 17 point something it will be. So that means what I'm supposed to do is check for all the prime numbers till 17. So I have to check divisibility by 2, 3, 5, 7, 11, 13, 17. That's it. If I get a factor till 17, if I get a factor till 17, then I can say that it's not a prime number. And if I don't get a factor till 17, then it will definitely be called as a prime number. Okay? As always, Pushkar, he is there to suggest you the right way. Right? That's what Drake does always. So check for 2, 3, 5, 7, 11, 13, 17. So it turns out that it is divisible by 7. Absolutely right, guys. It is divisible by 7. And that's why 301 is not a prime number. 301 is a composite number. Okay? All right. So how can I express a number in prime factor form? Say 120. 120 can be written as, say, 8 into 15. 8 can be written as 2 cube. So 2 cube into 3 raised to 1 into 5 raised to 1. So this form is called as prime factor form. That is splitting down a given number in terms of bare essentials, that is prime factors. After this, it cannot be factorized further. Right? Say 90. What can I do? 90 is 2 into 45. That's 2 into 5 into 9. 9 is 3 square. So 2 into 2 raised to 1 into 3 raised to 2 into 5 raised to 1. Correct? 111. That's 37 into 3. 98. That is 49 into 2. That is 2 into 7 square. 420. That is 42 into 10. That is 6 into 7 into 10. That is 2 raised to 2 into 3 raised to 1 into 5 raised to 1 into 7 raised to 1. Okay? Tables, absolutely right, Pushkar. I told you in the first session itself, tables are pretty much important. 2002. That's 2 into 1001. So 1001, if you see, is a special thing. That's 7 into 11 into 13. Remember this always, that 1001 is 7 into 11 into 13. Many a times in factorization or some other trick, this will be useful. So 2002 over here will be 2, 7, 11, 13. Okay? So identify which of the following numbers are prime and which are not. Harsh, for that we will see some tricks, but in the next session. Whenever we will do HCF LCM, so during that time, we'll see more techniques to do factorization faster. Okay? So 71 is the only prime number over here. That's absolutely right, guys. 71 is the only prime number over here. Rest are composite because 63 is divisible by 3, 117 is divisible by 3, 299, if you check, that is divisible by 13. It's 13 into 23. Okay? Pushkar, tables till at least 20. At least. If you can do more than that, that's good. but at least till 20 it should be learned. Squares at least till 30 and cubes at least till 10. Okay. Harsh, how to do D faster? As of now, there is no other way because we have not learned anything new. Again, there will be few divisibility tricks which we will learn in HCF LCM part. So that time we will see all this. Otherwise, as of now, I can just say that 299 approximate square root is 17 point something. So I have to check for prime numbers up till 17. I know for a fact 2, 3, 5, 7 are not working out. Try 11. So 299 by 11, that is also not working out. So 299 by 13, try. So 13 twos are 26, bacha 3. 39 is 13 threes are. So basically, actually doing it. Okay? Yes, China. Finding out roots and all will be done in the chapter 1.3. Surds, roots, and root surds and indices. So that time we will see all these things. Okay. Okay. Some other useful terms: factorials. For any natural number n, we can define factorial of n as n factorial is equal to n into n minus 1 into n minus 2 into dot 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 up to 3, 2, 1. Example, 5 factorial is equal to 5, 4, 3, 2, 1. Right? Similarly, 10 factorial will be 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Multiplication of all. So factorial basically means multiplication of all the numbers from 1 till that number. So in other words, if you observe just this part, can you say that this is n minus 1 factorial? Because this is multiplication from n minus 1 till 1. So this is n minus 1 factorial. So can I say n factorial is equal to n into n minus 1 factorial? That's like 5 factorial can be called as 5 into 4 factorial. Right? Can I say that? Okay. Let's learn factorials of first few numbers. It's always beneficial to remember these first few. 1 factorial is 1, obviously. One more thing, 0 factorial is also 1, by the way. 1 factorial is 1. 2 factorial is 2 into 1, that's 2. 3 factorial is 3 into 2 into 1, that's 6. 4 factorial is, no Nihal, factorial is not defined for negative numbers. 4 factorial is 24, yes, 4 into 3 into 2 into 1, that's 24. 5 factorial is 120, we just calculated. 6 factorial will be 6 into 120, that is 720, yes, very good. 7 factorial, can you tell me? That is 720 into 7. 720 into 7, that's 7 factorial, that is 5040. Check. 8 factorial, 40320, correct. And last 9 factorial, yes, still this. No Harsh, nothing is there. 362880, correct. 362880. So, last, can you tell me 10 factorial? 10 factorial should be simple. You just have to add a 0 to it. 3628800. That's it. Rahul, 0 factorial explain. Okay. ठीक है, एक काम करते हैं. All right. Rahul, are you okay with this fact? Underlying fact, are you okay with? So can I say from here that n minus 1 factorial is equal to n factorial upon n. So for example, put n equal to say 3. So can I say 2 factorial equal to 3 factorial upon 3? Or 4 factorial equal to 5 factorial upon 5? Similarly, can I say 0 factorial equal to 1 factorial upon 1? So thus 0 factorial is defined as 1. Okay? All right. Most welcome, Rahul. Okay? Factorials are very much useful in permutation and combination. But let's do one thing, guys. Let's stop over here for today. Whatever is remaining, we'll pick it up in the next session, because still there are lots of points to be covered, and let's not burden you a lot in the first day itself. So yeah, so remaining part we'll cover up in the next session, and post that we will be moving on to HCF LCM. Okay? So anything, suggestion, feedback, anything that you guys want to share, you can type it in the chat box. Any doubts that you have from today's session or in general, you can type it in the chat box. And otherwise, if you don't have anything, then we'll meet next time.